Ang safest way, kung nakikita yung mga video, ginagano nila, big, boy, di ba ngayon, tama? Raise, left, two, raise, car, young girls, back, Violeta, generally, wins. Siya, ako niya? Kung mag-measure kayo, please po, yan, para lang connected ko lahat. Ayaw makita ko. Pwede naman dito eh, kaso gumagalaw yan. Ako ha, mas maganda target nyo sa baba. Para steady. Gets ko? Tingnan yung diin ko. Hindi. Baka nakakagat ka, kita. Okay? So ang ginagawa dyan, hawakan nyo sa kabilang dulo. Okay po? At kakakamin mo sila pagano. Para mag-visualize nyo. Tingnan nyo ang mangyari dito, ha? At i-stress ko. Tingnan nyo ang simplify ko. Every na 1, every na 2, every end na yun.
In this very lab were a certain electronics engineering students gathered to perform an experiment filled with equipment that every student needs: chairs, desks, whiteboard displays, and most importantly, an air conditioning unit. We were tasked to read resistor color coding, to measure resistance using an ohmmeter, to use a breadboard to connect circuits, and to measure the total resistance of a series, parallel, and series parallel circuits. Now, in order to read the resistor color coding, we first must know what the parts are and how to decode them. This is an example of a resistor. It comes as 3 to 6 bands, with 4 being the common. In this 4-band resistor, the first 2 bands are the digit, the 3rd band is a multiplier, and the 4th band is a tolerance. Here is the table of what each color means. Then, how do we calculate the resistance in a circuit? Well, for series, we just add all the resistance values together. However, for parallel, we take the sum of the reciprocal of the resistance values and raise it to -1. For 2 parallel resistors, we have R total is equal to the product of resistor 1 times resistor 2 all over R1 plus R2. Then, what about series parallel, you ask? Well, that's up to you. I'm just here to give the basics and leave it to the B-rolls. Then, how do we measure resistance? Well, we can measure the resistance with the ohmmeter setting, here the multimeter. Here is a multimeter. We plug the black probe here and the red probe there and adjust the setting to its required need, and then we measure. We can measure the resistors by placing both probes at each end of the resistor. Now, I know some of you have already done this experiment, so here is camera A, a time-lapse version, and camera B, a stitched-up documentation of us doing it. The first part of the experiment revolves around computing and measuring the total resistance values in the given circuit. The results from the measured were then compared to the computed ones. The group observed that the 2 values showed minimal differences and were nearly identical, with only slight variations. And in this very paper shows what we have read, calculated, and measured. Wait, why is it blank?
It's just a prop.
And after all of that, next is adding a 9 volts battery source to the circuits, then calculating and measuring the actual voltage drop per resistor and in the circuit. To calculate the voltage drop, you can use old Ohm's law and Kirchhoff's voltage law. You may have fallen asleep already or checked your phone after all of that boring talk, but now it's time for your favorite part of the experiment. Actual live measuring while I'm discussing the results. Here is documentation of measuring the circuits while I go read this blank of paper. Understanding and learning how to analyze a circuit are standard knowledge an engineer must know. This trait allows us to know the basis of analysis about the interaction of components, their application, and their relationship in a circuit. This experiment proves the concept of both Ohm's and Kirchhoff's law. With the actual approach to the concept, we could see how the values vary from theoretical with a few causes to play. The biggest one is how tolerance contributes to the actual value of the resistor and battery instead of its perfect counterpart. However, the difference is, again, minimal and could still be considered true. Another trait we enhanced in this experiment is to properly troubleshoot the circuit for any error or mistakes that may occur. Drawing a circuit in our minds, then integrating it to the breadboard established our critical analysis, therefore recognizing our works entirely, making troubleshooting comprehensible. So there you have it. 2 lab experiments fully discussed and reported. Now with that said, I think it's time to get out of here before I catch an illness. Adios!